Filament guy. I'm over here at the Filament shop. So I was actually reading about something that I don't often hear people talk about. I've heard people talk about temperature and sunlight with filament and different things to that sort, but I don't often hear about water directly. You might hear about moisture or something, but so here I'm going to read a little bit about this. I got here on my Facebook. I just posted it about 5 minutes ago. Filament in water is one of those things people do not talk about as much as sunlight and heat, but it matters. First thing to understand is there are two different conversations. One is filament absorbing moisture before it is printed. That can cause popping, stringing, bubbles, weak layers, and ugly prints. The other conversation is how the finished print part handles water after it's printed. A 3D printed part is not automatically waterproof just because the plastic itself handles water. Layer lines, infill, wall count, nozzle temperature, and print quality all matter. Water can work its way through tiny gaps between layers. If something is going to be used around water a lot, like a fishing lure, handle, outdoor part, planter, or anything submerged, it may need extra walls, good layer bonding, and sometimes a clear coat, epoxy, resin, or sealant. PLA is usually fine for light water contact, splashes, or short-term use, but it is not the best choice for long-term water exposure. PLA also has a lower heat resistance, so leaving it in a hot car, direct sun, or warm outdoor conditions can be a bigger problem than the water itself. PLA Plus, PLA Pro, and Tough PLA are usually stronger or less brittle than basic PLA, but they are still PLA based and should not be treated like true outdoor or underwater engineering plastic. Silk PLA, matte PLA, wood PLA, stone PLA, glow PLA, glitter PLA, and other decorative PLA blends can look amazing, but they are usually chosen for looks, not water performance. Some filled or decorative PLAs can be more brittle or less consistent for functional parts. For something like a fishing lure, which is what I prompted this whole conversation from today. For something like a fishing lure, they can work for testing shapes and colors, but I would not call them the best long-term water material without sealing them. PETG is usually one of the better common 3D printing choices for water-facing parts, but it has better toughness and chemical resistance than PLA, and it handles outdoor style use better in many cases. PETG is still not magically waterproof when printed, but the material itself is a better starting point for things that may get wet. Basic PETG, transparent PETG, high flow PETG, and matte PETG can all be useful, but the print settings and layer bonding still matters a lot. Filled PETG like carbon fiber PETG or glass fiber can be stiffer and stronger in certain ways, but the additives do not automatically make it more waterproof. Those materials are usually more about stiffness, heat resistance, surface finish, and strength depending on the blend. They can also be abrasive, so the printer setup matters. ABS has decent water resistance and can be strong functional material, but it's harder to print because it likes an enclosure and can warp. ABS is also more commonly talked about for heat resistance than water resistance. It can be a good functional plastic, but for outdoor use, sunlight and UV exposure can still be an issue over time. ABS can also be smoothed or sealed with acetone vapor, which is one reason why people like it for certain finished parts. TPU is flexible, generally handles water contact pretty well after it is printed. It is useful for flexible parts, bumpers, grips, seals, feet, and things that need to blend. TPU does absorb moisture before printing though, so drying it can make a huge difference in print quality. For a fishing lure, TPU can make sense for flexible tails or soft parts, but not usually for rigid lure body unless that is a design goal. For something like a fishing lure, PETG is probably one of the more practical common choices, especially if it's printed solid enough and sealed afterwards. PLA can work for testing and short-term use, but heat, sunlight, and long-term water exposure are the weak points. ABS and TPU both have their place, but they are more specific depending on the design. So it's going to wrap us all up here. It says, the main point is simple. Water resistance is not just about the filament name. It is also about the print quality, layer bonding, wall thickness, and whether the part is sealed. A printed part can be made much more water resistant, but it should not automatically be assumed waterproof right off the bat. And I also want to add that as far as I know, there's a lot of layer lines with 3D printing, so that's why a lot of it's not considered food safe either or whatever. Anyways, that's my little rant on. I had to read pretty much word for word. Just wanted to kind of spread some knowledge. Maybe some of you just hear this as audio. I'm not expecting anybody to really watch it, but I'm trying to put out more content soon, longer content. I cleaned out my phone a little bit today. I'm thinking about upgrading a completely new phone just to get more space. Unless there's just an option just to upgrade it, obviously, then I'll do that. But yeah. Anyways, until next time.